everyone, and welcome to part 2 of the video on pre-experimental, experimental, and quasi-experimental designs. This presentation is on experimental designs. If you didn't get a chance to look at the pre-experimental designs video, please do so now, because in that video I go over the various annotations. That's annotations. That will also be in this video and the next one on quasi-experimental designs, and it's kind of important for you to know what those annotations are, unless of course you read the textbook or you were in class when I went over them, in which case happy viewing on this one. Okay, so let's get into experimental designs. What makes something experimental? Well, the answer to that question is random assignment. So I know in the pre-experimental video I said I would talk about this later, and now it is later. Random assignment is very important because it means that participants, or the people usually in the study, have an equal chance of being placed, aka assigned, to any of the study groups. So here we see the word groups. So that implies at least one or more groups will be in the study. And with random assignment, the key is that the people in the study were randomly assigned to one of those two groups. They were placed randomly. That means that they all initially had an equal chance of being selected. Now, this is not the same as random selection. Random assignment, random selection, both terms have the word random in them, so they can be confusing. But if you recall back to the sampling video, random selection is about how the sample gets selected from the population of interest. Okay? This is the sampling process, and it can be done randomly or non-randomly. But regardless, this does not matter when we're talking about random assignment. Random assignment happens when people have already been selected to be in the study. So they're already agreed, they have already agreed to be participants, and now if this was an evaluation of a program, the researcher is going to randomly put one group of people into the experimental group and the other in the control group. The experimental group is going to get the intervention and the control group is not. But the key here is that everyone initially had an equal chance of being put into one of those groups. This makes the two groups what's called probabilistically equivalent. This just is a fancy way of saying any differences between the study groups will occur randomly. So let's look at this word probabilistic. Probabilistically, probability. Probability is another word for random, right? And when we were talking about random selection. But initially, essentially, this is just saying that random assignment assures that the two groups are essentially the same because everybody had an equal chance of being picked, so any differences cancel each other out. And this is what we want when we're evaluating a program. This is the ideal sort of design that we can do, is an experiment, because we want to be able to say at the end of the day that it was the intervention that led to the effects that we saw and not any pre-existing differences between those two groups. Because imagine if we have two groups of people and both are depressed because they're at a clinic, but it turns out one group of people happen to be further along in their treatment, but the researcher doesn't know that, and they're not able to randomly assign the entire group of clients, then that's of course going to affect the results. So random assignment is gold in evaluation research, and that is why. Okay. So let's get into the first one, the pretest-posttest control group design. Just as the name suggests, we have two groups, random assignment in both cases. There is a pretest that's given to both groups and a post-test given to both groups. And here we have the control group. Just a side note on this terminology with regard to the word control. Technically speaking, control groups refer only to experimental designs. In quasi-experimental designs, they're referred to as comparison groups. Now, researchers will sometimes, even in a quasi-experiment, refer to the group that doesn't receive the treatment as the control group. But technically, that's the difference. Control, comparison. Okay, I think I have all of this in words. So here we go. We randomly assign people into two groups. One group receives the treatment, the other group does not. Before treatment begins, we give both groups some sort of measure. Let's say the Beck Depression Inventory, and this is a depression intervention. The intervention is administered, and then measures are taken again. The Beck Depression Inventory is taken again. Now, what would we like to see happen if our treatment was effective? We would like to see that the scores on the BDI are very high for both groups at post-test. After the intervention has taken place for one group and nothing for the other group, we would like to see the post-test BDI for the control group stay relatively high, unfortunately. Similar to what it was at baseline. However, for the intervention group, the one that received the treatment, we would like these scores to be low, especially compared to the baseline and compared to the post-test for the control group. Where'd my cursor go? There it is. Both groups here should be different. They should be the same here, different here. If we want to say that the intervention worked, which that's the whole point of doing this, is we want to say that. Okay. Then we have the Solomon 4 group design, which looks something like this. In this case, we take the pretest post-test control group design and add 2 or more groups. So these first 2 rows are just the design that we just went over with, right? The pretest post-test control group design. Now we've added 2 more rows, 2 more groups. And what happens? Well, the third group does not get the pretest, but does get the treatment and the post-test. The fourth group only gets the post-test. So why would we want to do this, right? The pretest post-test control group design here was working wonderfully for us. Why add the extra hassle of getting 2 more groups to be in our study, or people to be in our study and then assigning 2 more groups? Well, for a number of reasons. One is, if you recall back to the validity and reliability video, I was talking about the multiple testing effect, which is the idea that just by taking a pretest, that can somehow affect performance on the post-test outside of any effects of the intervention itself. So by not having the pretest, that kind of allows the researcher to account for any differences. And then in that case, we want that for both the group that receives the intervention and the group that doesn't. So I guess that was really one main reason. But if the intervention was effective, what would we like to see going on here? Okay, so think of it this way. Again, same example, depression intervention and the BDI. Here we have 2 pretests. We would like these 2 groups to be scoring high on the BDI, meaning they are both depressed. 2 groups get the intervention, 2 groups do not. For the group that did receive the intervention here, we would like to see a low BDI, especially compared to its own baseline and compared to the baseline of the control group. For the first control group, we would like to see no change from its baseline. So we would like to see a high BDI. Okay, this sounds really bad. Of course, we don't want to see high depression in anybody, but I'm just using this as an example. I feel the need to clarify this every once in a while. So back to what I was saying. So we would like to see a high BDI, low BDI, high BDI. Now this group we don't have a baseline for, but they received the intervention, so we would like to see a low BDI. In fact, similarly low as the first group, because these two groups received the intervention and random assignment says that they're both the same, essentially, so these scores should be similar. This group did not receive a pretest or the intervention, and they should be scoring fairly high on the BDI, similar to this group. Okay? So if we want to be able to say that this intervention works, that's what we would like to see. Okay, the placebo control group design. And as you're probably kind of seeing with this video and the previous one, all of these designs are trying to improve upon themselves to account for anything that might affect the outcomes at post-test. So here we have the placebo control group design. So we have 3 rows, so we have 3 groups. They are all randomly assigned and they all get a pretest and a post-test. One group gets the intervention, one group gets nothing, and one group gets a placebo. And even though I didn't go over this when I was talking about annotations, you all are probably guessing that this P stands for placebo. P, placebo. And you are correct. So what is a placebo? A placebo is usually used in drug trials where they're testing a new medication. And so it's usually in the form of some sort of sugar pill that one group gets. And the reason the researchers are doing that is because people have been known to sort of get better on their own if they believe that they are receiving some sort of new drug or new treatment or what have you. So this design is trying to account for the placebo effect, which according to the dictionary is a beneficial effect produced by a substitute treatment that cannot be attributed to the treatment itself and must therefore be due to the client's belief in that treatment. So the client believes that they are receiving a treatment and therefore they get better, even if they're not getting the new depression intervention in this case and they're just getting standard therapy. Oh, I adapted this from the Google Dictionary. It was worded a little bit differently, but this fits for our purposes here. Okay, so this is trying to account for the possibility that people might get better just on their own because they believe they're getting something special. So what would we like to see here if we want to be able to say that this intervention was effective? Well, we have 3 groups of people and they all came from a larger group that were all depressed. They were randomly assigned. So all of them here, because it's before anything happens, should have a high BDI scores, high depression scores. This group received the intervention, so at post-test we would like to see low depression scores, especially compared to baseline. This group received nothing, so we would like to also see that this group, not also, but we would like to see that this group scores are still high, especially similar to their pretest. The placebo group, remember, didn't get anything, or they got just sort of the standard treatment. So this score should still be low. I'm sorry, this score should be high. Now, if they are getting some treatment, we might see a lowering of this score, especially compared to their baseline, but it should not be as low as the new and improved treatment. Because keep in mind, well, yeah, so if this was the standard treatment and these were low just like the intervention groups, then at least we know that the intervention is just as good as the standard intervention. But if they weren't actually receiving anything, then this score should be high. Okay. The switching replications design looks complicated, but if you come with me on this journey of breaking down the design, I promise it will all make sense. It looks something like this. We have 2 groups of people, both are randomly assigned. We have a pretest Again, BDI, we want high depression scores here. And remember, time is moving forward this way. So let's say this is week 1. Week 2, the first group gets the intervention, the second group does not. Let's say this lasts 10 weeks. So now here we're at week 12, if I did the math right, which it doesn't matter, just go with me. Week 12. What would we like to see if this treatment was effective? Well, this part right here is just the pretest-posttest control group design. So we would like to see this score low, this score high. And then starting week 13 for another 10 weeks, the groups essentially switch roles, and now this becomes, the first group becomes its own control group, and then now the second group is the experimental group, and they get 10 weeks of the intervention. And then what would we like to see here? Well, we would like to see low scores here, indicating low depression. This shows us, one, that there were long-term effects of the intervention, and two, that we can replicate, essentially this is a replication of the pretest-posttest control group design in just one study. So I have some words here. It's called switching because the groups switch roles over the course of the study. It's called replications because the treatment is repeated or replicated. So why would this be a good design over the pretest-posttest control group design here? Well, because we're not denying people the intervention, we're just delaying it, so it's more ethical. Okay, I think no, there's a couple more. Okay, there's the I thought I was done. No, the multiple experimental group with one control group design. It's a mouthful, but at least it's descriptive. So here's what it looks like. We have 4 groups. Oh, wait, I probably have words here. 4 groups. There are 3 different interventions. That's what these subscript numbers indicate, that this is not the same intervention. 3 different kinds, or 3 different versions of one intervention. So what might that look like? So if it was 3 different interventions, we might have this new depression intervention. Then we have, let's say, CBT, and we have psychoanalysis. Okay, so we're trying to test which one is more effective or which ones are similarly effective. So we have multiple experimental groups with one control group. And there's the one control group. Okay, so yeah. The last one I want to go over for experimental designs is the factorial. This again looks very complicated, but once you break it down, it actually does make sense. So why would we do this? Well, we use this when we want to examine the interactions of different aspects of a treatment or intervention, because sometimes we want to go beyond just did this intervention work to what aspects of it did it work. Because if you think about like a treatment for depression, well, there's different variables that could be involved. There's the type of therapist. Is it a licensed social worker, an MSW? Is it an MFT, a licensed MFT, etc.? Is it once a week, twice a week? So there's different aspects. So the factors, this is the terminology that you should know. So the factors are the major independent variables that we might be interested in, like type of therapy or time in therapy. And then the levels are subdivisions or categories of those factors. For example, for type of therapy, we might be comparing psychotherapy with CBT. Time in therapy, we might be comparing once a week versus twice a week. So think of these as the independent variables, and then these as the categories. The levels are the categories of the factors or of the variables. And in terms of notation by way of the design box, it looks like this. Again, it looks complicated, I know, but just think of it this way, that this column is referring to factor 1, and this column is referring to factor 2. Sorry, I lost my alignment. There we go. So again, we have 4 groups, and these are different combinations of those 2 variables that we were interested in, type of therapy and time in therapy. So we have 4 groups. All of them are getting some version of the treatment, and observations are taken before and after. The BDI is administered before or after. So factor 1 is type of therapy. And there are 2 categories or levels. Level 1 is CBT. Level 2 is psychoanalytic or psychotherapy. Factor 2 is time in therapy, and the 2 categories are once a week or twice a week. So what does this mean in terms of these words connected to these notations? Well, let's take group 1. The first factor, remember this is factor 1 and this is factor 2. So we know this number refers to factor 1, level 1, 1, 1, 1, right? So we know they are receiving cognitive behavioral therapy, and this is factor 2, and it's a 1, whoops, so it's once a week. Let me do that again. 1, 1 means cognitive behavioral, well, I can't highlight. Cognitive behavioral therapy once a week. Group 2 is receiving cognitive behavioral therapy twice a week. Group 3 is receiving, now we're on 2, so it's psychotherapy once a week, because this is still level 1. This is psychoanalytical therapy twice a week. Okay, so they always line up in that way. So again, which group is receiving cognitive behavioral therapy? So that's a 1 twice a week, and that's a 2. So we look for a 1 and a 2. That's group 2. Okay. Now, this is a good way to sort of think it through and break it down, but in actual articles, research articles, you're not necessarily going to see a box in this way. What you're going to see is what's called factorial notation. So then you're asking yourself, well, why did you go through all of that? Because it helps you to understand this notation. Okay, so let's say I give you a 3x4 factorial design. What does that mean? Well, if we look at the number of numbers, how many numbers do you see here? Just looking here, how many numbers? I see 2 numbers. Well, the number of numbers tells you how many factors there are. I just said there are 2 numbers here, right? So that means that there are 2 factors because there are 2 numbers. So in this design, I know that the researcher looked at 2 independent variables. In this case, let's stick to our type of therapy and time in therapy. Okay. The values of those numbers, what these numbers actually are, tells you how many levels are in each factor. So remember, this is factor 1, this is factor 2. How many levels are in factor 1? There are 3 levels. How many levels in factor 2? 4 levels. So factor 1 has 3 levels, factor 2 has 4 levels. In our example of this being type of therapy and time in therapy, what could these categories be? Well, type of therapy, before we had CBT and psychotherapy. Now let's add group therapy. Okay. Time in therapy, we had once a week, so let's do once a week, twice a week, 3 times a week, and every day of the week. Okay, those could be, where's my cursor? The 4 levels. Now, what if you saw something like a 2 by 2 by 2? Okay. So we have 3 numbers, right? A 2 by 2 by 2, that means that there are 3 numbers. The first factor has 2 levels, the second factor has 2 levels, and the third factor has 2 levels. So if we compare it to the design notation that I showed you with the box earlier, right? We had, that was a 2 by 2. Let me go back so you can see that. This was a 2 by 2 because we have 2 factors and 2 levels in each. A 2 by 2 by 2 would just be adding factor 3. So let's say that was type of therapist, an LCSW versus a licensed MFT. Okay, so that's all I have to say about factorial notation and also experimental designs. Okay, so I will see you all. Well, I won't see you all, but okay, go on to the next video. Thanks. Bye.